All right, day two of volume week is volume of a pyramid. All right, and this follows in the footsteps of volume of a box, what we did yesterday. So let's start off with the base of a box here, but this is going to be a specific box. It's going to be a cube. Every dimension is going to be the same. So that means the bottom of our cube is a square, and I just gave it lengths of 4 by 4. We'll call them inches. So the area of the base, A of B, area of base of what's going to be a box is now a square. The bottom of a box is a square, is equal to 16. And if we turn our box into a cube by giving it a height, which is also 4, then it's 16 times 4. 16 times 4, the height is 4. And the volume of a three-dimensional shape is area of the base times the height. 16 times 4 is 64. So that's the work that you did yesterday, and it would actually be inches cubed. All right, so that's the box. Now, if I take this other square that we have here, that's going to be the base of a shape, and turn this into a pyramid instead of a box, it would look something like this. So that would be our pyramid. Now, hopefully, and I give it the height of 4 as well. Now, the height of a pyramid is usually shown in the middle of the pyramid, from the tip at the top all the way down to the middle of the base, the square at the bottom. So those have the same dimensions. They're 4 by 4 by 4, but hopefully it's easy to see for you that the pyramid is going to be smaller than the box. You're not going to be able to fit as much sand or water or whatever material you have inside this pyramid as you would inside the box. So this is going to be a fraction. The volume of the pyramid is going to be a fraction of the volume of the box. But what is that fraction? Well, here's how I try and explain it to you with another picture. Here's a cube. Every dimension is the same. And I've tried to draw a pyramid inside the cube with the same base. But that pyramid doesn't go all the way to the top of the cube. It only goes halfway up. Now, if you imagine a pyramid like that coming in from all 6 sides of the cube, it would fill in that cube perfectly. All right, I'm going to draw another one from the top. So there's another pyramid from the top, and if they touch right in the middle, that would fill up the top, the bottom, and then you could have a pyramid that same size coming in from each side, the front and the back. That'd be one for each side of the cube, and it would fill up that cube perfectly. So basically, those pyramids are 1/6 the volume of that cube, because you could fit 6 of them in that cube. So what is the volume of the cube? Well, the volume of the cube is just x to the third power. What does that mean? Well, it's really length times width times height. Length times width times height. But the length, the width, and the height are the exact same things because it's a cube. Everything is the same in a cube. So if we could just use one letter, because it's the same. If length is 4, then so is the width and so is the height. So it'd be 4 to the third power. But since we're not putting numbers to them, I'm just going to say it's x. So x to the third power is the cube. Well, the pyramid was 1/6 of that. 1/6 x to the third power, because you could fit 6 of them in there. Well, what were the dimensions of the pyramid? Well, the pyramid was x squared times 1/2 h. All right, x squared is the area of the base. It's length times width, and we're using x for our length, width, and our height because they're all the same. So the pyramid is area of the base, x squared, times half the height, but we want that to equal 1/6 of x to the third power. So we have to multiply this by 1/3. 1/3 times x squared times half the height is equal to 1/6 x to the third power. Now, that's confusing. It's kind of complicated algebra, but basically you get 1/6 x equals 1/6 x to the third power on each side if you multiply this out. X squared times x is x to the third, and 1/6 or 1/3 times 1/2 is 1/6. I'm going to change that h to an x because we're using x for all our dimensions. So you get x squared times half x, that's area of the base times the height of our pyramid. And how do we get our sides to balance up? We have to have a 1/3 in there. So it's 1/3 area of the base times the height. Area of the base is x squared. The height is 1/2 of x for our pyramid. So it was 1/3 area of the base times the height, and that's the formula for a volume, area of the base times the height. And if you take 1/3 of that, then you get the pyramid. So that's where it comes from. The good news for you is that you don't have to understand this or remember any of that. All you need to know is that the volume of this pyramid is 1/3 the size of the volume of that box. So I guess I gave you a bad example because 3 doesn't go into 64 evenly, but it basically would be like 21 1/3 would be the volume of this pyramid because it's 1/3 of 64. And if you divide 64 by 3, you get 21 1/3. And that's the homework tonight. So you're going to do it the same way as yesterday. Area of the base times the height with one more step. Divide it by 3 or multiply it by 1/3. The pyramid is 1/3 the volume of the box.